New physics sim trains robots 430,000 times faster than reality. Genesis can compress training times from decades into hours using 3D worlds conjured from text. So we're going to be reading through this article. Thought it looked quite interesting. There's a couple of short videos in here that we can watch too. So a simulated teapot and letters created using the Genesis platform. We'll cover all of these things. So, by the way, if you like these videos, don't forget to leave a like and subscribe if you like me reading these articles, and feel free to recommend some. So, on Thursday, a large group of university... Oh, by the way, this was posted 19th of December. I've had it open for a while. So, on Thursday, a large group of university and private industry researchers unveiled Genesis, a new open-source computer simulation system that lets robots practice tasks in simulated reality 430,000 times faster than in the real world. Very specific number. I guess we'll get into that. This is a interesting website. We might leave this for now. We can always get back. I think these are the videos shown in the article anyway, so we'll get back to that. So the accelerated simulation means a neural network for piloting robots can spend the virtual environment equivalent of decades learning to pick up objects, walk, or manipulate tools during just hours of real computer time. So it's just an accelerated simulation which just does these tasks over and over and over for hours. And yeah, like I said, it's basically the equivalent of doing it for decades if a robot did it in the real world, I suppose. So sort of like the meme for that Interstellar. So 1 hour of compute time gives a robot 10 years of training experience. 10, that's crazy. If you think about as well the like 10,000 hour rule of becoming an expert in something, it's sort of crazy that you could teach AIs to do something for 1 hour, and that would be like a human doing something tens of thousands of hours. Anyway, that's how Neo was able to learn martial arts in a blink of an eye in the Matrix dojo. Yeah. Who played a minor part, in quotation marks, in the research. Fan has previously worked on several robot simulation projects for NVIDIA. Moonshot to create embodied human level AI in robot form. Let's get rid of the sound here. We're going to get distracted. We always do. Here's some robots doing some funky things. That's showing us what's happening. I do think humanoids look cool. Anyway, I think we probably don't need to get distracted by this. This is Genesis, Eureka with GPT-4. Robots can learn much faster. Same sort of thing. It's essentially just performing tasks virtually. So Genesis arrives as robotics researchers hunt for better tools to test and train robots in virtual environments before deploying them in the real world. Fast, accurate simulation helps robots learn complex tasks more quickly while reducing the need for expensive physical testing. So you can see a real need for that. I mean, just this sentence alone, 1 hour of compute time gives a robot 10 years of training experience is crazy. If it's good experience, then it's like, I mean, it's crazy. You could basically teach a robot in an hour to do anything, right? Genesis arrives as robotics researchers. I've just read that. For example, on this project page, the researchers show techniques developed in Genesis physics simulations, such as doing backflips, being applied to quadruped robots and soft robots. Show me the... I think it'll be these ones. This is just the same one as this, so maybe this is loaded already. Cool, you can do it. I don't know why these aren't playing. Being a bit laggy. It's funny because the video is playing, but the frames aren't updating. Oh well. But we get the point. They can do backflips. The Genesis platform developed by a group led by Zhu Shan. Sorry, terrible pronunciations. I can read this maybe. Of Carnegie Mellon University processes physics calculations up to 80 times faster than existing robot simulators. Okay, so 80 times faster is quite good. Like Nvidia's Isaac Jim, I've not heard of that. It uses graphics cards similar to those that power video games to run up to 100,000 copies of a simulation at once. Cool, so it's all in parallel, makes sense. That's important when it comes to training the neural networks, yeah. If an AI can control 1,000 robots to perform 1 million skills in 1 billion different simulations, then it may just work in our real world, which is simply another point in the vast space of possible realities. Let's read that again. So if an AI can control 1,000 robots to perform 1 million skills in 1 billion different simulations. Okay, yeah, I see what they're saying. So basically, yeah, put a whole bunch of different environments and doing the same skill, the same one skill in a billion different environments, and doing that for a million, doing that for each robot. So generating dynamic worlds. So here we've got a couple of videos we can look at. Hopefully they will actually play. We might have to open them in Chrome if they don't. I don't know if it's like a Firefox issue. So the team also announced they are working on the ability to generate what it calls 4D dynamic worlds, perhaps using 4D because they can simulate a 3D world in motion over time. Time is the fourth dimension here, that makes sense. So the system, but it's just a 3D video, right? The system will reportedly use vision language models, VLMs, to generate complete virtual environments from text descriptions similar to prompts in other AI models. We've seen plenty of those. So the AI-generated worlds will reportedly include realistic physics, camera movements, and object behaviors, all from text commands. Okay, that's fine. So should we have a look if this plays? Let's make that full size. Okay. Here's some fruit bouncing, some water, rabbit melting, chocolate rabbit I should say. So I'm guessing all of these are generated from text. Some of these are a bit abstract. I feel like the physics on these is probably quite hard, so that's quite good. Cool, and that's a glass cup filling with examples of 4D dynamical and physical words that Genesis created from text prompts. This prompt-based system may let researchers create complex robot testing environments by typical natural language commands instead of programming them by hand. Okay. Traditionally, simulators require a huge amount of manual effort from artists. This sounds true. 3D assets, textures, scene layouts. Yeah, it would be like building a game, right? So yeah, this would definitely be really good. Using its engine, Genesis can also generate character motion, interactive 3D scenes, facial animation, and more, which will allow for creation of artistic assets for creative projects. I think some of those tools already exist, of course. Yeah, I mean, anything that produces sort of has graphics, essentially, will be impacted by this. Let's have a look at this. Is this a Wukong character? I've not played that game. I have heard it's good, though. Let's watch that again. Pretty good. Examples of character motion generation from Genesis using a prompt that includes a miniature Wukong holding a stick in his hand, sprints across a table surface for 3 seconds, then jumps in the air and swings his right arm down during the landing. Cool. While the generative system isn't yet part of the currently... Okay, so there's some GitHub code. Okay, that was the GitHub repo. Where is the repo code? So we don't have the generative AI stuff yet. I might kind of keep an eye on this because it would be cool. It looks like you can literally just do pip install Genesis world. And I'm not sure what we can do with it currently. So it's a physics engine capable of simulating a wide range of materials. I'd have to have a play around with it. Maybe we can do that. There's some instructions. So it's under active deployment, so keep up on that. If you're on GitHub, you can star that and keep up with it. It'll be quite cool to get the generative AI stuff. So the reason it stands out from other 3D world simulators for robotics training by Python for both its user interface and core physics engine. Other engines use C++ or CUDA for underlying calculations whilst wrapping them in Python APIs. Genesis takes a Python-first approach. I mean, I love Python, but won't this just make it slower? Surely using C++ and then wrapping it in Python is faster. I guess it always depends on your goal. So, although I guess you could also argue that like training time doesn't matter too much because once it's trained, you can deploy. Who knows? I don't really care about stuff like that, to be honest. Just like use whatever tool you want to use, and if it's good, people will use it. If it's not good, people won't use it. It's pretty simple. But anyway, that's it. So yeah, leave a like and subscribe if you enjoy watching me read articles. If not, then don't. And yeah, thank you for watching.